In this section, we want to discuss the rate of change for different functions. But before we get into that topic, we want to first review the concept of slope. Anytime we have a linear equation of the form y equals mx plus b, written in slope-intercept form, then we have two key components for that equation. Our value for m, which is the slope, and our value b, which is the y-intercept. We'll focus primarily on slope here, since that's going to tie into our concept of rate of change. We know from previous topics that slope can tell us whether a line is increasing, meaning that our slope is some positive value, if our line is decreasing, meaning that we have some negative value for our slope, if our line is horizontal, which is the case where our slope is equal to 0, or if our line is vertical, and that's the case where our slope is undefined. If we're not given that equation in y equals mx plus b form, or if we're not given the equation at all, we can find the slope of a line by investigating its graph and identifying 2 points, x1, y1, and x2, y2. Once we know 2 points that our line passes through, we can plug those into the slope formula, which we evaluate by taking the difference of the y values divided by the difference of the x values. Keeping in mind that this formula is exactly the same thing as y1 minus y2 over x1 minus x2, meaning the order of the values doesn't matter as long as we stay consistent. If we start with our second y coordinate in the numerator, we need to start with our second y coordinate in the denominator. If we start with our first y coordinate in the numerator, then we need to start with that first x coordinate in the denominator. In example 1, then, we want to find the slope of the line that we have graphed here. We can find two nice points where we have whole number values at 0, 2, and 3, 0. This means we can calculate the slope as 2 minus 0, the difference of those two y coordinates, over the difference of our two x coordinates. Since I started with y equals 2 in the numerator, I need to start with x equals 0 in the denominator, since that's that xy pair. So we'll have 0 minus 3 in the denominator, giving us 2 over negative 3, or negative 2/3. In this case, we see that the slope is negative, which makes sense since our line is decreasing as we read that graph from left to right. What we also know from the slope is that value of negative 2/3 is telling us to find a second point. We go down by 2 units and to the right 3 units. So the slope of this line is negative 2/3, and regardless of which 2 points we chose on the line, we would come up with that exact same value. That is, lines always have a constant slope. The rate of change or finding a next point would always be by moving down 2 units and to the right 3. That would always land us on another point on the graph.